Hey, in your math books, page 350, we're going to continue working, graphing on a coordinate plane, but we're going to be talking about polygons today. So a polygon is a closed plane figure formed by three or more line segments. So a line segment is a straight line, right? That intersect only at their endpoints. Okay. So what do we notice about this first figure? Is it a polygon? Are all of the lines straight? Do they connect? Would that be a polygon? Okay, what about this second figure? Is it a polygon? Tell me why. There's that opening there. They don't all connect. What about the third shape? Is it a polygon? Tell me why. They're not straight lines. Okay, so a polygon is a shape that's all closed and it's formed with straight lines. Right, so you can classify polygons by the number of sides they have. Triangles, how many sides does a triangle have? What? Louder? Because tri means three. Like a tricycle, how many wheels? Three. How about a quadrilateral? How many sides? Four. How many of you ride quads? You call them four-wheelers. The four-wheelers, you call them quads. Why would we call them quads? Four wheels, right? Pentagon. Well, how many sides is that? Five. Okay. If you think of a pentagram, it's like a star because it has 5 points, right? So penta is five. Hexagon. How many sides? Six. Okay. Decagon is 10. Octagon would be 8. Okay. So describe the polygon with vertices. So the vertices, that's these points where they meet. All of those are vertices, okay? So with 2, 5, 7, 1, 2, -6, -3, 1. Okay, 2, 5, how would I do it? Left or right? You guys got to be louder. Left or right? Right, how many? 2, then what? Up 5. So there's our F. Okay, 7, 1. What do I do? Which way over? Right, how many? And then up 1. So that's G. 2, -6. Right 2, down 6. That's H. -3, 1. Left 3, up 1. And that's J. Then I'm going to connect. Okay. How would you classify that polygon? What would it be? What? Quadrilateral. Why? The quadrilateral. How many vertices does it have? Say it louder. 1, 2, 3, 4, because those are the 4 that we plotted, right? 4 sides, 4 points where they meet up. If it was a pentagon and it had 5 sides, how many vertices would it have? 5, yep, and so forth. If it was a triangle with 3 sides, how many vertices would it have? 3. All right, an architect is drawing a plan for a part of a bridge that makes a right triangle. What's a right triangle? Huh? Well, it has 3 sides. What else does it have? It has that 90-degree angle in it, right? So that's what makes it a right triangle, okay? So you can see there's his right triangle. The coordinates of two vertices of the right triangle are -3, 5, and 2, 4. Okay, so let's plot that first. First, we're going to plot point A, -3, 5. Tell me what to do. Left 3, up 5. So there's A. 2, 4. Right 2, up 4. And that's B. Sides AC and BC will form the right triangle. What must be true about a right triangle? 90 degrees, right? Is there more than one possible location for the vertex C? Where could we put C? Trying to think. A, B. Where's one place I could put it? Would that work? Would it? Because then if I draw my lines, there's AC and B to C. Would that make my right angle? And then if I connect A to B, it's a tiny one, but it works, right? Is that the only possibility? Where else could I put it? Could I do it up here? Could I go right there? And then if we connected, this would be AC. Would that work? Nope, that one wouldn't work. Where at? Huh?
So it's over 2, up 5.
Right, there we go. Over 2, up 5. So we could put it right here. So then right here, trying to get different colors so you can see, there would be our right angle, right? Correct, right there. And then we would connect. So what are the possible points for that right angle? What's one of them? What's the one Katie told me? This one right here. 2, 5. What would be the possibility for that one there? -3, 5. So the vertex, which vertex is the right angle? Oh, wait, no, not -3, 5, -3,
4.
we put it right here, 4, sorry. So this would be C, and then B, and then A. Which vertex is the right angle, A, B, or C? Where's that right angle at? Right here, correct? So it'd be at C. Yeah, angle C. Okay, is this a polygon?
Yeah.
Yes, tell me why. They're all connected and they all have straight lines. If they gave us just 3 random points on a triangle, sorry, on a coordinate plane, would they always be a polygon? Or would they always be a triangle? Yes or no? Because what if I plotted like this? Would that make a triangle? No, right? Okay, turn the page. An architect is designing a plan for a new building inspired by the Nykredit Kristallian building in Copenhagen, Denmark. The building will have faces that are parallelograms without right angles. So this is a parallelogram. What it means is that these sides go on forever without touching. That's what parallel means, right? And these sides will go on forever without touching. The architect plots 3 of the 4 corners of one face. Who gives us that? What are the coordinates of point T if T is the 4th corner? All right. Point Q, -5, -2. What do I do? Left 5, down 2. That's Q. Okay, now what? R, 1, -2.
One right.
1 right, down 2. That's R. S, -2, 3.
Left.
Left 2, up 3. So that's S. Okay, so if we would want, let's see, here to here, here to here. We need to draw our 4th point, right? Can I just randomly pick a spot up here and know that it'll work? Would it have to be the same length as this one? So how many units is this? 1, 2, 3, 4, 5, 6. So how far from S should our last point be? 1, 2, 3, 4, 5, 6. So that would be T. And then straight down. Okay. Is there more than one possible location for that?
No.
No. Okay. Okay, you can classify polygons by the number of sides they have. Okay, point A. Okay, I want you to graph these really quick. Okay, remember the first is over, left or right, and then the second number is up or down. So go ahead and do it, please. And then connect the dots, A to B, B to C, C to D, and then D back to A. What would we call this one? Nope. Number of sides. I get what you mean, yes. But what are our number of sides? How would we classify it? 4, quadrilateral. Quadrilateral. Okay, moving on. Okay, over here, Wesley designs a shark fin for a costume. He chooses those points to model the fin. So go ahead and graph the points on the coordinate plane. You're gonna then connect your dots, K to L. Okay, make sure you pay attention. K to L, M to N. Oh, so just go in order. K, L, M, N, P, and then back to K. Hey, how many sides does this have?
3. Oh wait, there's 1.
Okay, right here. Because if it was just 1, it would keep going straight. Does that keep going straight? So here's 1. From here to here would be the second one. From here to here would be. From here to here would be. And from here to here would be. Again, how many vertices does it have, or points? 5. So the same number of sides, the number of sides is the same as the number of points. So if it's 5 sides, what could we call it? Pentagon. Okay, this one here, is that a polygon?
Yes.
Yes, tell me why. All sides are straight and all vertices connect. Is 4 a polygon? No, tell me why. It's got that curved top, right? Not a polygon. Let's look at the homework. Okay, number 1 and 2, you're going to tell me yes or no. Is it a polygon? If no, tell me why it's not. Okay, so right here, if it is not, explain why. Okay, 3 points A, B, and C are 3 vertices of a parallelogram. Plot the 3 points on a coordinate plane. What is it about a parallelogram? Remember, it's like an italic square, right? An italic square or an italic rectangle, right? What do we know about these 2 sides of a rectangle? They're the same length. What do we know about these 2 sides of a rectangle? Same length. So you need to remember that. So they give you 3 sides. You have to figure out where the 4th side goes. Okay, and then plot it and give me the coordinates. Okay, cross out 4. Okay, here they want you to make a right triangle. They give you 2 of the 3 points. You have to figure out where the 3rd would be. Okay. Number 6, you're graphing the points and connecting them to form a polygon. Number 7, graph the points. Connect the points in order from A to D. And what names could you use to describe the polygon? I'd have to point it. I'll have to do that to tell you how many there are. Diana's drawing, here's that word again, a parallelogram on a coordinate plane. She plots those 3 vertices. Select all the possible coordinates for the 4th one. Oh, so here and here, right? There are 2, let me just show you. There are 2 possible vertices because you could go from here to here, right? And then it would be over here somewhere, correct? Or you could go from there to there and it would be over here somewhere, okay? So you're going to have 2 possible points. Cross out 9. 10, a farmer gets paid $3.75 per bushel of corn. How much does the farmer get paid for C bushels of corn? P represents the pay. So we want to know how much he gets paid, right? So P equals $3.75 per bushel for each bushel. How would I find that? Right, 375C. Good job, Katie. Okay, questions. Okay, how about if it doesn't get done, it will be homework.